I'm creating this video for a 1974 Mercedes 450 SL, basically showing how the ignition amplifier, which is right here, number 5, how that interacts with both the coil and the distributor and the points here, okay? And basically it's going to be the same for, I think, 73 to 1980. However, caveat being that after 1976, you have a fuel distribution system change whereby the injectors are driven mechanically, changes in pressure, etc., versus 1974, in my case, the injectors are opened and closed electronically. Okay, so that's kind of an important distinction. But nonetheless, the purpose of this video is to show how the ignition amplifier, which is a common failure in these cars, how it interacts, again, with the coil and the distributor. And basically, we start with number 1 here, which represents the starter key in your car. You sit in your car, turn the key on, etc. It basically powers the coil through these individual resistors. You have 1 resistor, 2 resistor, represented by 2 and 3. Okay, and basically what this does is it drops the voltage down. It starts at 12 volts, drops it down to approximately about 8.5, 9 volts, etc. to the coil. And the reason it does this is that in the instance that you powered the car on and walked away, the coil would be powered up at 9 volts, okay, and would not melt, okay, because again, you're powering up this distributor, okay, providing power to these to the actual what are called points, okay. And the idea is you don't want to melt your points, and again, 12 volts, which again, if you didn't have these 2 resistors, you know, in situ here, that they would essentially provide, wouldn't it basically prevent you from providing a full 12 volts to the coil, okay. So that's pretty important. And again, just to back up in basic ignition, that this coil, we're talking about very archaic technology. This coil would be found in a 57 Chevy in essentially, the premise here is that you power up the coil and you interrupt, you create a voltage within the coil and then you break it, okay? You take away the ground and cause a spark, okay? And that spark essentially connects to the distributor. There's an arm in the distributor which turns and powers an individual spark plug, okay, which is represented, there are 8 in this instance, we're talking about a V8 engine, and distributes the spark depending upon, you know, where the crank and camshaft are accordingly, okay? So having said that, this technology is very archaic. It's 1957. Number 4, number 6 are very archaic, okay? Now in this instance, in a 57 Chevy, as I've illustrated, the fueling delivery system, it's a carbureted system. So it's metered by a carburetor, which is a Venturi, which is an entirely different carburation system. Here, in this case, you have a 74, which, as I mentioned, is a fuel injected type of system, right? So because of that, you need to introduce a amplification device that basically gets a response from this distributor and modulates it and sends it to the ECU. And the ECU is essentially a fueling mechanism, okay? And I won't discuss it, nor will I discuss the inner workings in this video of the ignition amplifier, but the ECU basically determines when the injectors fire, i.e. when they're opening and releasing fuel into the particular combustion chamber. And it takes a variety of cues. It takes cues from the position of the distributor. It takes cues from the engine temperature, the manifold pressure, okay? Meaning that if you're at idle, you've got a higher manifold pressure, you're wide open throttle, you're at an absolute almost zero pressure. So it takes all of these cues, processes it, and determines, there's a fueling map that takes basically, there's an algorithm that determines when, like I said, duration, when those injectors fire, etc. Okay, but in this particular instance, you need to understand, as I mentioned, these two resistors, which are ceramic resistors, they're dropping down the voltage in the case of a key left on, engine running position, cranking position. Okay, when the engine's cranking and not starting, cranking, you're getting a full 12 volts given this dotted feed right here. So you're getting a full 12 volts because when you're starting an engine, you need more power to the coil. Okay, so in that brief instance, when the car is turning over, it should be a brief instance, you're getting a full 12 volts as opposed to 9, what it drops down to. Okay, now having said that, when the car is running, and again, this represents right here the points mechanism, the points, and these are mechanical points, much like you'd find in a 57 Chevy or a 1966 MGB, etc. They're opening and closing. As this distributor arm turns, it's opening and closing these points, and what it's doing is it's collapsing the field, okay, the voltage field within the coil, okay, and causing a couple of things: the spark to fire, okay, that's represented by number 4, okay, and also is opening and closing and sending a signal to number 7 to the ignition amplifier. And again, the ignition amplifier, as I've illustrated, is the amplifier down here. That's, in the case of a 74, it's mounted in the firewall, or mounted inside of the fender, inside the fender well. And in the later models, it's mounted actually within the firewall, within the engine compartment on the inner driver's side fender. Okay, so basically, as it's interrupting the coil, causing a fire, causing a spark to occur in the ignition coil, it's also transmitting to, again, if we look at this, it's transmitting to number 7 in the ignition amplifier, which again, if we look at our diagram, number 7 is within this circle here. Okay, the circumference of that represents the ground. The number 7 actually represents the signal that's being sent to the ECU. So it's using the same information that the coil is using to cause a spark. It's sending that same information to the ECU. Okay, to tell the ECU, okay, this is when spark is occurring, get ready for fueling, etc. And again, I mentioned not only the moment of the spark occurs, but you're taking cues from manifold pressure, engine temperature, and there's a couple of other cues that it receives. But nonetheless, that shows you how those two interact, or how those two devices, the ignition amplifier and the ECU, interact together. So that's basically the understanding there. So at the end of the day, if you're trying to diagnose an ignition issue, if you still get a spark, and you do it the conventional way, you take out a spark plug wire, you connect a very good spark plug, put it into the spark plug boot, ground it. Okay, don't touch it when you're turning over the engine, but just lay it on a known ground and see if it's sparking. Okay, that's going to tell you if these various segments, your ignition key, your coil, and your distributor and points are functioning, if you see a spark, right? But if the ignition module has run its course and is no longer functioning, you're not going to be able to transmit this information via number 7 back to the ECU. And again, it gets information from number 7 in this particular diagram and transmits information to the ECU, TD, right here, transmits it to the ECU. So again, if you have spark, it doesn't necessarily mean that those injectors are firing. You could put a Noid light in line to see if your injectors are firing, but nonetheless, just wanted to give a basic understanding of how the ignition amplifier integrates with the ignition coil and the distributor, as well as the points here.